This is a continuation of Unit 2A review, starting with number 11. All right, number 11 asks us to write the equation of the line in slope-intercept form that is parallel to this line and passing through the point negative 15, 2. So again, let's start with point-slope form. Y minus y sub 1 is equal to the slope times x minus x sub 1. And then let's go looking for what we need to put into the equation. We need an x1, y1 value. Well, we're given a point that lies on this line. So here's our x1, there's our y1. And then we also need to find the slope. Now, the slope of the line we're looking for is parallel to the slope of this line. So let's remember how to find the slope of this line. This equation is written in standard form, so we can quickly find the slope by taking the opposite of a divided by b. In this case, that would be, well, let's see, a is positive 3, so its opposite would be negative 3. Let's divide that by negative 5. And a negative divided by a negative gives us positive 3/5. Okay, this is the same slope. It's the same linear equation that we used in number 10. So you shouldn't be surprised that we have the same slope. Now, parallel lines have the same slope, right? If two lines are parallel, then their rise over run is going to be the same. Okay, so if this line has a slope of positive 3/5, then any line parallel to it will also have a slope of positive 3/5. All right, so we have our slope. We have our x1, y1 right here. So let's plug that information into our equation. Y minus the y value of our point is 2, and that's equal to a slope of positive 3/5 times x minus the x value of our point. Now we're subtracting a negative 15, so that would be the same thing as adding a positive 15. All right, solving for y, we'll start by distributing on the right side to get rid of those parentheses. So rewrite the left side as is. Y minus 2 is equal to 3/5 x. And then we're taking a positive times a positive, so this would be plus. Now, 3/5 of 15. Well, 1/5 of 15 would be 5, but I don't want 1/5, I want 3/5. 3 times 5 is 15. So 1/5 of 15, I'm sorry, 1/5 of 15 is 3. We don't want 1/5 of 15, we want 3 times that. 3 times 3 is 9. All right, and then one more step to solve for y. We want to add 2 to both sides. And we get y equals, well, I did it again, I forgot my x. There we go. Y equals 3/5 x plus 9 plus 2 is 11. All right. Now, let's take a look at number 12. Okay, kind of the same type of problem, except we're just given more different information. Write the equation of a line in slope-intercept form that passes through these points. Okay, so we could take 2 of these points, find the slope, and then pick a point to put into slope or point-slope form. But remember, we're being asked to find this, or to write this equation in slope-intercept form, which is y equals mx plus b. That means, what are the 2 things I need? I need the slope and I need the y-intercept. Well, if you take a look at our table of data right here, take a look at this point right here. X value of 0, y value of negative 5, isn't that our y-intercept? Okay, the y-intercept is the y value when x is equal to 0. So therefore, we already have our b. Okay, we have part of what we need. The only other thing we need is the slope. So let's take any 2 points. Okay, let's just pick these first 2 points and use the slope formula. Just a quick reminder, to find slope, we take the difference in y's over the difference in x's. It's a ratio of a difference in y's over difference in x's. So let's just use these 2 points right here. So I'm going to take the second y value minus the first y value and put that in the numerator. That would be negative 7 minus a negative 1. Subtracting a negative 1 is the same thing as adding positive 1. And then in the denominator, we'd have negative 1 minus 3. That would be this, negative 1 minus negative 3. That would be the same thing as negative 1 plus positive 3. Okay, negative 7 plus 1 is negative 6. Negative 1 plus 3 is negative 2. And then negative 6 divided by negative 2 is positive 3. So there's our slope. We've got our slope. Okay, we've got our y-intercept right here. Let's just plug 3 in for m, negative 5 in for b, and we're done. Y equals a slope of 3x, and then the y-intercept is negative, so we're going to write minus 5. All right, let's move on now to number 13. Now we're going to start talking about our piecewise functions. Okay, so number 13, we have a graph of a piecewise function. All right, and we need to fill in these blanks here. Okay, this graph is in pieces. We get different output values depending on the size of our input value. It looks like when x is less than or equal to positive 1, okay, our output is along this graph. Now this graph should look familiar to you. It is not the parent quadratic function, it's a transformation of the parent quadratic function. You can see that usually the vertex would be here, but this has been shifted down 2 units. So the equation of that part of the graph, or that part of the function, would be x squared minus 2. Okay, then once our input values are bigger than 1, notice we have this constant output. The y value of every one of these points is negative 1. So f of x is negative 1 when x values get bigger than 1. So we're going to write x is, now notice here that 1 is included in the first part of our piecewise function. And this is a function, so 1 should only have one output value. When 1 goes into this function, we put it into this part of the function. So that means we need to say that the output is negative 1 for all x's that are strictly greater than 1. If we have a less than symbol up here, we do not want to have a less than symbol down here, or we won't have a function. Okay, number 14. This graph is in 3 pieces. Looking at it from left to right, it looks like the output value is x for all x's that begin at negative 5, okay, and end at 0. Now notice in the middle part of our piecewise function, 0 is not included in the middle part, so we need to include it up here. So we'd say our output is x as long as our input is negative 5 less than, notice the open circle, so we're going to keep that strictly less than x, which at the same time is less than or equal to, this part of the function ends right here when x is 0. Okay. Then the middle part of our function is the square root of x function for all x's just to the right of 0 up to and including 4. And then the last part of this piecewise function is determined by a transformation of the parent absolute value function. Notice that the vertex usually is here, but this has been shifted 6 units to the right because that's what happens when you subtract 6 from the x value. So our output is determined by this rule. Absolute value of x minus 6 if x is, now notice 4 is included in the middle part, so we need to say strictly greater than 4. All right, so that is Unit 2A review up through number 14, and so you'll want to click on the next video to continue with this review.